वेलकम स्टूडेंट। आज हम देखेंगे महाराष्ट्र स्टेट बोर्ड 12th केमिस्ट्री एक्सरसाइज सॉल्यूशन और आज का हमारा टॉपिक है केमिकल काइनेटिक्स एंड न्यूमेरिकल प्रॉब्लम्स। सो विल स्टार्ट। आज हम देखेंगे वन इंस्टेंट क्वेश्चन। सो क्वेश्चन इज द हाफ लाइफ ऑफ a first order reaction is 0.5 minute. Calculate time needed for the reactant to reduce 20% and the amount decomposed in 55 seconds. So in this question there are two sub questions. So let's start. Solution. So first we have to determine the rate constant of the reaction. We have given that T half, that is half life, is equal to 0.5 minutes, that is 30 seconds. Now rate constant K is we have to find out. So the formula is K is equal to 0.693 divided by T half. This is the relation between half life of first order reaction and rate constant of the first order reaction. Now substituting the values, we get K is equal to 0.693 divided by 30. That is K is equal to 0.02310. By simplifying this mathematics, we get K is equal to 0.02310 per second. So here is the log. We know that log of 0.693 is equal to bar 1.8407. Here there is a division, so we have to minus log of 30. So log of 30 is equal to 1.4771, and by subtracting this value we get bar 2.3636. Now anti-log of bar 2.3636 is 0.02310. So this is the rate constant for the given first order reaction. Now we have to find out the time needed to reduce the reactant to 20%. So given that here percentage is given, so initial concentration of the reactant A naught is equal to 100, and we have concentration of AT is equal to 20. Now time needed for the reactant to reduce to 20% is equal to T is equal to question mark. We have to find out it. Now we have K is equal to 0.02310, that is rate constant. We have to calculate it in previous step. Now formula is K is equal to 0.303 divided by T log of concentration of A naught divided by concentration of AT. Here K is the rate constant, T is equal to time, A naught is equal to initial concentration, and AT is the concentration after time T. Now by substituting the value we get 0.02310 second inverse is equal to 2.303 divided by T log of 100 divided by 20. Now 100 divided by 20 is 5, so we get T is equal to, and also by rearranging we get T is equal to 2.303 into log 5 divided by 0.02310 second inverse. Now log 5 is 0.6990, so we get the equation T is equal to 2.303 divided by 0.02310 second inverse into 0.6990, which is the log for log 5. Now the LHS of this equation is solved by logarithm. So here is the log. In this equation 2.303 is multiplied by 0.6990, so we have to add the logs values of these two values. So log of 2.303 is equal to 0.3623 plus log of 0.6990 is bar 1.8445. Now addition of these two values is 0.2068. Now from this sum we have to subtract the log of 0.02310 because which is in denominator. So minus log of 0.02310 is bar 2.3636, and by subtracting this value we get 1.8432. Now the anti-log of 1.8432 is equal to 69.69. Therefore the T is equal to 69.69. So this is the time needed for the reactant to reduce to 20% of the initial amount of the reactant. Now next we have to find out the amount decomposed in 55 seconds. So let's see the solution. Determination of amount. We are given that concentration of A0 is equal to 100%, that is initial concentration. Time t is equal to 55 seconds. And we have to find out amount decomposed in 55 seconds, that is concentration of A0 minus concentration of AT is equal to question mark. So we have again K is equal to 0.02310 second inverse. Now again we have to use formula, that is K is equal to 2.303 divided by T log of concentration of A0 divided by concentration of AT. By substituting the values we get 0.02310 second inverse is equal to 2.303 divided by 55 second log of 100 divided by concentration of AT. Now rearranging we get log of 100 divided by concentration of AT is equal to 0.02310 second inverse into 55 second divided by 2.303. Now we have to solve this part by using log. So here is the log. Log of 0.02310 is equal to bar 2 minus 3636 plus, because there is a multiplication, so log 55 is equal to 1.7404. By adding this we get 0.1040. Now from this sum we have to subtract the log of 2.303. So log of 2.303 is equal to 0.3623, and by substituting we get bar 1.7417. Now we have to find out the antilog, and the antilog is 0.5517. So we get log of 100 divided by concentration of AT is equal to 0.5517. Now we have to shift this log to the right side. So we get 100 divided by concentration of AT is equal to antilog of 0.5517. So antilog of 0.5517 is 3.562. So we get 100 divided by concentration of AT is equal to 3.562. Now again rearranging we get concentration of AT is equal to 100 divided by 3.562. Now we have to calculate this value by using logarithm. So here is the log. Log of 100 is equal to 2.0000 minus log of 3.562 is equal to 0.35516. So by substituting we get 1.4484. Now antilog of 1.4484 is equal to 28.08. So we get concentration of AT is equal to 28.08%. Now we have to determine the amount decomposed in 55 seconds. So concentration of A0 minus concentration of AT is equal to 100 minus 28.08, and this value becomes concentration of A0 minus concentration of AT is equal to 71.92. So the amount decomposed in 55 seconds is 71.92%. I hope you like the video and enjoy. Thank you.